Hello everyone, my name is Oleg Berzin and I'm a co-chair of the Linux Foundation Edge Akraino project. I'm happy to present this episode of the MEC Tech Series titled DevOps MEC Infrastructure Orchestration. In this episode, we will learn how major industry trends influence MEC infrastructure, how infrastructure as code can be used to apply DevOps framework to building and testing MEC infrastructure, and how open source projects help build tools for orchestrating MEC infrastructure and services. Among the major industry trends influencing MEC infrastructure are the following. Public cloud-driven edge computing, where edge computing infrastructure and resources are increasingly provided by the public clouds, such as AWS Outposts. Hybrid infrastructure. In most practical deployment of edge infrastructure and applications, an application deployed at the edge needs services residing in one or more public clouds. Multi-domain. Individual domains such as edge, cloud, and network present their own APIs and provisioning methods, making end-to-end deployment challenging in complexity and time. Therefore, a multi-domain orchestration solution is required to handle all domains in a uniform and consistent manner. Interconnection and federation. The need for efficient and performant interconnection and resource distribution between edge clouds and core clouds and between distributed edges proximal to the end users. Bare metal orchestration. Many orchestration solutions assume that the bare metal hardware and the basic operating system resources are available for the deployment of applications, which may not be the case in all scenarios. And developer-centric capabilities, where end-to-end infrastructure activation, application deployment, configuration, and interconnection are part of a continuous integration and continuous delivery environments that are called DevOps. So how do the emerging capabilities such as infrastructure as code help in this situation, and how do they work? We'll look at the example of Terraform. Terraform is an infrastructure as code tool that helps define cloud and edge resources in human-readable configuration files that could be versioned, reused, and shared. It can be used to create consistent workflows for defining this infrastructure, as well as managing low-level components such as compute, storage, and networking resources, as well as higher-level components such as software as a service features. The cycle consists of writing the programs, planning the workflow, applying the programs to the infrastructure, and then eventually destroying the infrastructure in order to be able to repeat the cycle as part of the DevOps process. So how can a Terraform tool be used for orchestrating the MEC infrastructure? In this example, we show an orchestrator that implements Terraform as a microservice. That means it can be run without the human intervention and driven by a workflow engine. It can retrieve Terraform programs from a Git repository. It can respond to the API calls that carry data and parameters that enrich the Terraform programs. In this case, the orchestrator is effectively acting as a CPU, running the programs and adding the data and parameters to it. And the orchestration can start with creating infrastructure in the public cloud, creating infrastructure in the edge cloud, like bringing up bare metal hardware, installing the operating system, installing Kubernetes and virtualization on top of it, creating connectivity between the two domains. And this process represents a uniform way of representing the infrastructure. It's a model-free orchestration, meaning that the orchestrator doesn't really need to know the details of what happens in the individual domains. It just runs the program and executes the steps. It's DevOps driven because of the process of creating, applying, and the ability to delete and iterate on the infrastructure. And it stores the state of the actions externally in the Git repository as part of the orchestration process. So how does this all apply to MEC? The orchestrator can be thought of the MIO, MAPM, and Vim. The MEC Federation Manager could implement API calls, triggering the actions by the orchestrator on the domains that are represented here, and interfaces such as cloud resources, MEC platforms, as well as the network resources such as interconnection. So now let's briefly take a look at an example of an open source project that is used to implement this type of orchestration. The project in question is Public Cloud Edge Interface Akraino Blueprint, It basically provides an orchestration layer and edge capabilities and open APIs to interwork between the various domains, the public cloud core, public cloud edge, third-party edge, which could be any edge computing infrastructure, as well as the operator network edge that is interconnected together and reside in different data center facility domains. So now let's take a look at the internal structure of the Akraino PCEI orchestrator. The orchestrator is referred to as the PCI enabler. It has the infrastructure enablement module. It has the application and function deployment module, the infrastructure as code microservice, the ability to invoke Kubernetes APIs and application distribution tools, the workflow engine, multi-tenancy features and service onboarding and definition capabilities, the API handler, and the user interface and design studio for a software that could drive the orchestrator. The developers store their code such as Terraform plans, application deployment charts, and the configuration playbooks in the Git repository. The orchestrator is able to work with multiple public cloud providers, edge providers, interconnection providers, and use various forms of southbound interfaces in order to communicate with those providers. The operators are able to invoke the orchestration workflows through the API calls into the orchestrator. In addition to the infrastructure deployment capabilities, the Akraino PCEI project can be used to deploy MEC services. Let's take a look at this on the example of the MEC Location API. The specification of the MEC Location API developed by the Etsy MEC ISG could be used to generate the server code, containerize the server code, and make it usable in Kubernetes. This is all part of the Akraino DevOps process. The generated service could then be onboarded into the PCIe enabler orchestrator. This orchestrator could be used as described to deploy infrastructure resources, like, for example, in this case, a bare metal server, and then the onboard and deploy the actual MEC Location API service. This is part of the PCI blueprint implementation as part of the Akraino project. And then the Location API client could be used to actually implement the API request and responses for this service. In summary, in this podcast, we learned how major industry trends influence MEC infrastructure, how the concept of infrastructure as code could be used to apply DevOps framework to building and testing MEC infrastructure, and how Akraino Public Cloud Edge Interface Blueprint enables orchestration of MEC infrastructure and services. If you're interested to learn more, please follow the links on this slide. Thank you very much for your time and attention.